Hi students, good morning all of you. Today I am going to talk about the chemistry of Borazine. So Borazine is basically a compound of boron atom. Now I am going to teach about the preparation of Borazine and their properties and the structure. Now, how can we prepare Borazine compound? So Borazine is basically prepared by three different methods. Now, in first method, Borazine synthesized by the pyrolysis of the adduct of diborane and ammonia at 453 to 473 Kelvin temperature. Now, this is the full reactions. First, diborane reacted with ammonia, it will form this kind of adduct. When this adduct further heated at temperature 543 to 573 Kelvin temperature, then it will provide the Borazine compound with the evolution of hydrogen gas. In case of second method, for the preparation of Borazine, that Borazine also prepared by the direct reaction of diborane with ammonia at 523 to 573 Kelvin temperature under 1 atmospheric pressure. For this reaction, the percentage of yield of this Borazine is 50%. Now, this is the whole reaction scheme given here. When diborane reacted with 3 equivalent of diborane reacted with 6 equivalent of ammonia with under 523 to 573 Kelvin temperature and 1 atmospheric pressure, it will form a borine complex, and this bond represents the coordinated covalent bond. Further, this is also an adduct. Further, this borine complex further polymerization, it will provide the Borazine compound. Now, coming to the preparation of Borazine, there is another method when ammonium chloride reacted with boron trichloride at 413 to 423 Kelvin temperature in presence of chlorobenzene, it will provide tri-boron chloroborazines. And further, when this tri-boro chloroborazines further reacted with sodium borohydride, it will provide Borazine. So, this reaction is basically involves two steps. In the first step, when ammonium chloride reacted with boron trichloride, it will provide tri-boron chloroborazines. When this tri-boron chloroborazines further reacted with sodium borohydride, then it will provide the Borazine, and with the evolution of diborane. This is a byproduct, and it will provide also sodium chloride salt as a byproduct. Now I am going to talk about the structure of borazine. As you know that the molecular formula of borazine is B3N3H6. So borazine is basically a 6-membered ring structure with the presence of alternative boron and nitrogen atoms. The structural studies of borazine shows that it is a 6-member planar structure, and like benzene, and the bond distance between boron and nitrogen is 1.44 angstrom, and the angle between boron, nitrogen and boron is 120 degrees. Now, infrared and Raman spectra studies shows that these infrared and Raman spectra, these are all spectroscopic analysis. So, these two spectroscopic analyses, that means infrared and Raman spectroscopic analysis, shows that the structure of borazine is planar, and the bond distance between boron nitrogen is 1.44 angstrom. And this bond distance lies between, for single bond like 1.54 angstrom and double bond 1.36 angstrom of boron nitrogen bond. This suggests that the structure is basically a resonating structure like benzene ring. So now you can see that borazine, it has alternative boron, nitrogen, boron, nitrogen, boron, nitrogen, and these are all present in a 6-membered cyclic form, and each of these boron and nitrogen atom directly attached with 6 hydrogen atom, and there is a lone pair which is present in the nitrogen atom and which is basically directly delocalized to the this 6-membered cycle like benzene. Now there is a question came in every exam like NET, GATE or any university exam, why borazine is called inorganic benzene. So you have to explain with proper reason. Now borazine is called inorganic benzene because of the following reason. So first reason is borazine, it has a 6-member cyclic compound like benzene, where the ring positions are occupied by boron and nitrogen, and in an alternate position like benzene, there is a system of conjugated single and double bond. Now borazine undergoes addition and substitution reactions with HCl and bromine, etc., like in the case of benzene. The ring structure of borazine also related to the layer structure of boron nitrogen like structure of benzene. That is why it is called inorganic benzene. Now I am going to talk about the properties of borazine. So at ordinary temperature, that means at room temperature, Borazine is, or that means Borazine does not react with air and oxygen, but when Borazine reacted with water, it will provide boron dihydride compound, and this hydrolysis takes place in the above 423 Kelvin temperature. Now, when Borazine reacts with 2 equivalent of bromine at 273 Kelvin temperature, the resulting compound decomposes at 333 Kelvin to give dibromoborazine. So now this is the reaction scheme. So this is the structure of Borazine. When this Borazine reacted with bromine, 2 equivalent of bromine at 273 Kelvin temperature, it will form a addition product. Now, I think this structure is wrong. Here you have to add another 2 bromine in this nitrogen and this bromine. Then further, if you heat it, this compound, it will provide dibromoborazine. So there is a huge similarity present in case of Borazine and benzene. Borazine, in contrast to benzene, readily undergoes addition reaction with hydrogen halide like hydrogen chloride, hydrogen bromide, methyl iodide, methanol and water. In the last 2 cases, very mild condition must be used. Either disruption of ring occur. 1 mole of Borazine adds 3 mole of the above molecules. The more negative group in the addition normally goes to boron atom. So, dear students, please watch this video of the chemistry of Borazine, and I would like to say you just read carefully. I will make another video of pseudohalogen and polyhalite compounds. So stay safe, stay happy, stay at home. Thank you very much for your watching. Bye.